So now we're ready to find a tangent line. So if your function is defined on an open interval containing c, and the limit as delta x goes to 0 of our difference quotient, c plus delta x minus f of c, if this limit exists, and I'm going to call it m, exists, then the tangent line to f at the point c f of c is the line through that point, through c f of c, with slope m. So this tells us how to find our tangent line to our function at a point. So let's look at an example. Let's say our function is 2x minus 3, and I want you to find the slope of the tangent line to this function at the point at x equals 2, c equals 2. So if we're finding the slope of the tangent line, that's m, which is the limit as delta x goes to 0. And we're going to plug in c is 2 plus delta x minus f of 2 over delta x. So what we're going to do is we're going to plug in this 2 plus delta x in place of x in our function. So you'll get 2 times 2 plus delta x plus 3 minus, and now plug in 2 into our function, 2 times 2 plus minus 3. These should be minus 3's. So now I'm going to simplify the numerator. I'm going to distribute this first 2 right here across. So you'll get 4 plus 2 delta x minus 3. And I am going to go ahead and distribute this minus, so it'll become a minus 4 and a plus 3. And now you should see that this 4 and this minus 4 cancel, this minus 3 and this positive 3 cancel. So what I'm left with is the limit as delta x goes to 0 to delta x over delta x. And now the delta x's cancel. And I'm left with the limit as delta x goes to 0 of 2. But 2 is just a constant, and so this limit is equal to 2. And that is the slope of our tangent line at c equals 2. The last thing I want to mention is if you go back to the function we started with here, the function was y equals 2x minus 3. And if you look at the slope of this, what's the slope here of this line? The slope is 2. And so something special happens here, which we'll go into more later. But because we started with a line here, the slope of the tangent line is the same as the slope of that line.